farmers, trust is everything. At Genesis Fertilizers, we're not just proposing to build a facility, we're building a future designed for you. With real progress already underway, we're closer to providing Western Canadian farmers with a reliable, locally produced fertilizer supply. Now is the time to take control of your farm's future. Learn more at genesisfertilizers.com/credibility.
Thank you to our show sponsors, the Farm Safety Roundup, the Pulse School, and Real Ag on the Weekend. In partnership with Rocco Radio at Saskatoon, Real Agriculture is pleased to present Real Ag on the Weekend with host Sean Haney. Listen live Saturdays at 4 p.m. Saskatchewan time on 650 CKOM Saskatoon and 980 CJME Regina. Find it wherever you get your podcasts. Hello, everyone. Welcome to the Agronomists. I am your host, Lindsay Smith, and I am pretty excited about tonight's episode. It might be a little out of the wheelhouse for some of you, but hey, it's always fun when we're learning together. Thanks to everybody already in the comments saying hello. It looks to me like Farmer Schneck, you are in just a little bit south of me, just enough that it was probably about 10 degrees warmer today, I swear. Anyway, I hope the weather is treating you well where you are and that you are getting ready for the upcoming holiday season. We do have a show before we get started tonight. Did want to remind everybody we do have a show next week. So December 23rd, we will have Peter Pete Johnson and Ray DeBanco joining me for the year-end wrap-up. If you've got a favorite topic or favorite guest from the year that you want us to mention or talk about or expand on, let us know. We will definitely, I'll be picking clips this week and we'll be working on that show for next Monday. So check that out, of course, on Monday, 8 p.m. Eastern right here. And if you collect those CEU credits, make sure you head to realagriculture.com/agronomists. Let us know you watched this show and get those CEU credits collected as well. I'll have you know, everybody, that I am also a teensy bit exhausted after the news cycle today. It has been a very busy one, and my brain is tired. So I'm going to do my best. But oh, Dinah, that was a big one today, and of course, not done yet. But let's. Okay, so tonight's topic, we are talking about pulse production. We're going to focus on, of course, some of the benefits, but yes, some of the challenges, and we've got some pretty significant ones on the root rot disease side that we're going to touch on. But we'll open up the floor, of course, for questions as we go through our conversation. But for now, let's bring in our guests for tonight's conversation. We've got Laura Schmidt with the Manitoba Pulse and Soybean Growers and Michelle Hubbard with AAFC Swift Current. Welcome here, ladies.
Thanks for having us, Lindsay.
Yes, happy to be here.
All right. Okay. So let's start out with, I know both of you have been on the show before, but it's probably been a while for most of the people following along. So we'll start with Laura. What keeps you busy with Manitoba Pulse and Soybean Growers? What do you do there?
All kinds of things keep me busy, that's for sure. So yeah, I'm a production specialist. So that is largely farmer facing, lots of support for farmers and agronomists on all things pulses and soybeans. And we're going to talk about pulses today, but I have to be honest about my biases here coming from Manitoba. Soybeans, we lump them right in with about 1.3 million acres of soys. And then our pulses we're rocking around 200,000 acres of peas and dry beans. So those are my big pulse heroes, and dabble a little in the fabas for fun. But I'm going to lean on Michelle for some of our lentils here and chickpeas for sure.
Mm-hmm. Fabas are beautiful when they flower. Hideous when you harvest them. Like, they are just the ugliest bean out there. Yeah. Anyway, Michelle probably is going to tell me I'm wrong. But Michelle, tell us about your work there at Swift Current. What do you work on there?
Well, I'm a pulse pathologist, so I focus on diseases in pulses. And for me, that's chickpea. The ascochyta blight in chickpea is the big one. And then I also work on a chickpea health issue where we don't know really what's causing it.
Yeah.
And I have some work on anthracnose of lentil, and then a lot of work on root rot, of course, primarily in pea.
Right. Which we are going to unpack quite a bit of that tonight. Jason Vogt just wants to talk about dry beans. Sorry, Jason, we have other things to talk about. Um, just kidding. I'm sure they'll get a mention. Michelle, can we touch on just quickly so everybody sort of knows what we mean? This mystery disease with chickpeas. What's the background there? This is a couple of years, I think, that this has been going around, and we're trying to sort of sort this out. What do we know so far?
Well, it was first came to anyone's attention in 2019 in
Okay.
southwest Saskatchewan, and so even farther south of where I am in Swift Current. So really in the part of where chickpeas are grown, where it's quite dry. And the symptoms are leaf tips turning white, wilting high up in the plants, or yellowing or potentially dying. But it's different from just drought stress because drought stress would be lower down in the canopy
Right.
and would come with things like the nodes being closer together. And then
Mhm.
it sometimes co-occurs with ascochyta blight, but sometimes
Okay.
there's no ascochyta blight present.
Right.
And so some of the suspected causes at the moment are, well, a combination of stress factors, drought, nematodes, maybe nutrient deficiencies, especially potassium, or maybe
Okay.
phosphorus fertilization, and then maybe changes in the microbiome in the soil.
Not a short list, Michelle. Like that,
No,
that
and
sounds
that's
like
not the whole list.
that's
That's kind
not
of
the
the
whole
top
list. Yeah.
candidates at the
Yeah.
moment.
Exactly. Okay. So you'll be busy for a while. Yeah. Okay. So interesting. Maybe it's nematodes. And then maybe you could get like a beneficial nematode and just throw it out there. And then away we go. I know I like to oversimplify things, guys. So there you go. We'll touch base on some of those things, maybe not. Mark says transparency here. Define lentils. Oh my goodness. Okay, so Michelle, let's just touch on quickly because there aren't any lentils that I know of in Manitoba. I do know of one farmer in Ontario who has successfully grown lentils on a very small scale, but they have grown them and actually have sold them individually, like in individual packs because they didn't grow that much and they had nowhere else to sell them. But red and green lentils, for the most part in Canada, do we have? I know there's several classes between each, but do we have brown lentils and those sorts of things, or is it mostly just red and green in Saskatchewan?
Mostly red and green.
Yeah, I
I
don't
think
think there's
there
any
is
brown.
a little bit of black or beluga lentils and maybe some
Yeah,
brown lentils, but red and green are certainly the
yeah.
main market classes.
And I was also my idea of Christmas lentils, of mixing the green and red, was shot down many, many times. I'm told that is an admixing. That's bad. That's all bad. So there you go. Now, Laura, I do want to touch on, because of course you are Manitoba Pulse and Soybean Growers. You did mention over 1 million acres of soybeans, obviously. Soybeans do fix their own nitrogen, but we don't call them a pulse. They're not a pulse. Do soybeans, let's just get this out of the way, do they get a nitrogen credit for the following crop? Do soybeans leave anything for the next crop?
No.
Okay,
Let's go
thanks.
into details. So the lovely what are a pulse? It's the dried
Yeah.
seed of a legume crop. So soybeans are with peanuts in that they're a legume, but it's not the dried seed that we're using. So they're actually an oil seed. Um, they do produce their own nitrogen. They produce a lot of it for themselves, and then they take it off the field in the grain. So there's not a lot left there for the next crop. We kind of call them net neutral when it comes to nitrogen credits. We don't expect much for that next crop. They're taking a lot with them.
Okay. They are just a bit self-serving. Let's put it that way. Okay.
Well, if we
Um,
talk about phosphorus, I mean, now they're just straight
okay.
hog. So
Okay. See, these are very good things to know. Okay. So now, certainly, and as we've mentioned tonight, one of the key things with pulses is that they do tend to like drier conditions for all sorts of reasons, and so they tend to be grown in our more arid regions. But the disease complex is, of course, one of those that still occurs in those dry regions, but in wet years tends to get even worse. So I do want to sort of start off with, from the challenge perspective, I do want to start off with root rots because we kind of have to, because we have, of course, a major one with Aphanomyces, but Aphanomyces isn't necessarily all on its own out there. So Michelle, maybe I'll start with you. Um, Aphanomyces is, as I understand it, it is a native disease to the prairies, but really has reared its head relatively recently. Um, what was this? What did it look like this year as far as rates in the province of Saskatchewan this year, as far as if we're getting ahead of this, or is it really just spreading and really dependent on the weather?
It's really, I wouldn't even say it's spreading. It's just really dependent on the weather. If it's wet, it's likely there, and it's just waiting for the right opportunity and for people to grow peas and lentils too many times in any given field.
Now, what is too many times though? Because I've heard anything from 1 in 8 years to 1 in 10. So, what do we know what's enough of a rotation?
Not really, and it really depends on the site and the weather and a lot of other factors that we're still sorting out. Like
Yeah.
we've wrapped up. It was actually Dr. Shamma Chatterton in Lethbridge who led the study, but we're just wrapping up a trial on a rotation with a resistant pulse. So chickpea or soybean or faba beans count as a Phanomyces
Right.
resistant pulse. And so what we are trying to find out there is how many break years do you need between, by break years, I mean a year without pea or lentil. And then does it make a difference if it's just a break where you grow cereal or canola or mustard, or if you include a chickpea or a faba bean or a soybean in
Mhm.
there? And generally, we were hoping that these resistant pulses would be better than the alternative, that they'd cause those resistant oospores to germinate but not complete their life cycle, and we'd actually get less disease. But that's where the results are kind of all over the place and mostly weather dependent.
Mhm.
And it seems like the resistant pulses are resistant, but how long of a break you need really depends on the weather and on what the inoculum was like to start with, and on probably other soil factors that are not completely understood.
Yeah. Now, so Laura, when it comes to obviously Manitoba, parts of Manitoba, I don't want to overgeneralize, parts of Manitoba, wetter, other parts to the drier side. Um, Certainly, as you mentioned, dry beans, yes, there's peas also grown in the province. On the root rot sort of complex, what have the challenges been in most recent years?
Can we pull up a picture of the root
Of
rots from this
course.
year? Just
That
because
is, I think,
I'm a
number
visual talker.
3. Okay, I like it, Laura. We can do visuals. We got them and they're great. I think it's slide 3, producer Jay.
Yeah, there we go. So that's a lovely
Ta-da!
photo of peas from northwestern Manitoba this summer. The big drone shot, that's from first week of July there. So you can see those roots. They are just rotted. There's not much for nodules left. Those lateral roots have completely sloughed off. And then, yeah, 20 days later, this thing had very quickly ripened. And this was kind of the story for a lot of northwestern Manitoba peas this year, unfortunately. But they weren't the only crop to struggle in those saturated soils. But just really love that photo. But you talked earlier about that. How long of a break do we take between these host crops for Aphanomyces? Is it 6 years? Is it 10 years? We throw around a lot of numbers. And it comes down to, what was that situation the last time peas or lentils were in that field? Did it look like this? Because then we're talking about a really high oospore load for the future years. We want to take a longer break. 10 years is probably where we're going to head after some of these fields this year. When we talk about, how widespread is Aphanomyces in Manitoba, those soil test results are still being processed for this year. But if we look at the previous 5 years, 86% of the soils we've tested across Manitoba in our disease surveys have come back positive for Aphanomyces. It's just lurking and waiting for that soil moisture to swim to infect our pea roots, and we'll really see that devastation here. When we think about our dry years we had before, we can lean towards that 6-year break between pea crops if we have Aphanomyces in a field, and that's all if that Aphanomyces is there. But we also have to talk about its really, really fun little friend, Fusarium.
Right.
Because when we talk about our root disease surveys that we do across the province, we find Fusarium in every single field every year when we're looking at pulse crops and soybean crops. And it's always co-infecting with Aphanomyces. So it's kind of that 1-2 punch, have to manage both of them to really kind of bring this down. A lot of that comes down to that soil moisture and how saturated those soils are staying. So not every field's going to be suited to peas. That's typically why we'll see them more often in our well-drained kind of western fields in Manitoba. But they can be grown successfully around this issue. We just have to kind of be aware of it after kind of a wet year we just came out of.
Now, the question always, of course, comes up with seed treatments, whether or not seed treatments are effective for root rots. Now, it's my understanding. So, how do you balance that question, Laura? And if I see a field like this, now obviously you're right. I might wait a solid 8 years before I go back to peas, maybe something like that. But root rots, generally speaking, what's the advice on seed treatments, and what's the caveat with something like potentially a Phantomyces?
Well, I think we need to be honest in our expectations of our seed treatments to kick it off, right? That's only going to last 3 weeks after planting. We do expect that to wear off after a while here, and these peas are going into pretty cool soils. While a Phantomyces generally prefers a nice warm soil. We'll see those symptoms start to show up kind of a week or two after a nice warm June rain, after that seed treatment's already kind of worn off in our soil. So we need to be, first of all, realistic in our expectations. They're part of the tool in the toolbox for management, but they're not going to be a complete solution. So we've actually been running some fungicide PC treatment trials on farm with field scale farm trials. We love talking about those. So we've done those for 2 years, and it's with a product that has activity on a Phantomyces as well. So far, we're still not really seeing a long-term result that's going to impact yield, but there's other questions we're trying to address with that. Does having that early season protection maybe lower the oospore load for successive years? When we come back to that field, will we see something longer term? Or will it just help that crop get established enough that that root mass is just so much better off and more resilient when we actually get hit with some of that soil moisture coming into June? So I'm a big fan of always, putting it in the field. Let's do an on-farm test. Let's take a look at these under the scope. But I think we also need to be realistic in how much we expect out of these products long-term, because it's just a piece of the puzzle.
Mm-hmm. Michelle, your thoughts on our expectations with seed treatments? Do we expect too much out of them at times?
Well, Laura's absolutely right that they're great for 3 weeks at the most. And so they're great for getting your crop going. And in the case of chickpea, they can be, depending on your soil, they can be absolutely essential. Like in the Swift Current area, if you don't seed treat your chickpea, you'll get just a few plants in every square meter. But for pea and root rot, yes, they'll protect you against early season, but absolutely the plants will get root rot later.
Yeah. And what is the chickpea disease that knocks them out so
Like
completely?
like Pythium or Rhizoctonia,
Okay.
a seedling rot, basically. So if you were to dig up the seeds, like I've done a test where I went and took some of the soil back and brought it into the greenhouse so I could know exactly where the seeds were, and the seeds were just like a little ball of mush after a few weeks if you didn't seed treat them.
Yeah. Gross.
And
Laura?
if you really watered these pots, you'd get virtually 0%
No.
germination.
Yeah.
Just everything
Okay.
rots. But
Yeah.
then at fields like 20 kilometers away in Hodgeville, you can get pretty good emergence without a seed
Right.
treatment. There might not be a really noticeable difference with or without.
Okay.
Another one on the seed treatment one that I get fired up about, and you brought it up, so this isn't on me, is the insecticide seed treatment for peas and faba beans. We've got pea leaf weevils in Manitoba. They've been moving in, and we've been trying to address that question of, do these seed treatments kind of help us get these nodules established? Do we see longer term effects? Because all the benefits of growing that pulse crop is that nitrogen fixation, and now we've got an insect that's coming and stripping the plants of them. So that's another fun one to address as we go, and it's really just those peas and faba beans that they seem to love. So another question we're looking at on farm and with some small plot trials too.
And pea leaf weevil is the one that it notches the leaves, right? And also means if you're seeing that, it's too late if you didn't do anything about it, right? So you could do something next time. But
well, yeah, and the
the
notches just
plant's
let you
already
know
there.
they're there.
Yeah.
Those don't actually cause any yield loss, but they're laying eggs on the soil, and then the larvae are burrowing below ground, and then they live in the little nodules, and they hollow them out, eating them as a food source. And so the notches are just, they're there. If you dig those up come flowering, you might have fewer nodules than you expected. They look like little bird houses because they're all hollowed out. Yeah.
Yeah. Weevils are Yes. What is it? The lesser of the weevils? Okay. Now, Pete
Use
has a
that.
good question. Yeah. Pete has a great question about genetic resistance. And Michelle, I think you touched on this, but this has definitely been one of the questions for the pulse breeders and for the pulse varieties that we have as to how quickly can we develop resistance to Aphanomyces. Is this thinking about the disease itself, is this going to be a very tough one to address with genetics?
Well, that is an excellent question, and there's a ton of work going on for genetic resistance. And so for peas, we're much farther ahead than we could be. So, like, the short answer is yes, there is some genetic resistance in peas, but no, it's not complete. In the best case scenario, it might reduce the severity a little bit. But so it is, and it's not what we call in plant pathology major genes, where it will just
Right.
completely stop the disease. That's not how it works, even in the best possible scenario. And then we're much farther ahead than we could be because there's been decades of work in France where they identified Aphanomyces as an issue decades ago. So we're able to take some of the same genetic regions or chunks of DNA
Right.
from that breeders have used in France or in the United States. And so there are varieties coming and coming potentially fairly soon. But the danger with them is that they're not going to eliminate root rot and
Right.
the pathogen evolves. There's some evidence coming that there's a lot more diversity in Aphanomyces than it just
Mm,
being one monolithic thing.
right.
So it has the potential to overcome this resistance, and the resistance could completely stop working.
Hmm.
So yes, there's genetic resistance and more is coming, but there's actually only a limited number of genetic regions in the
Right.
pea genome that confer this resistance, so they can be stacked or put together in the same pea. But even
Mm,
if we do that, they can be overcome. And so if it's
yeah.
overused, we grow pea repeatedly in the same fields, it's going to be useless
Yep.
Yeah, it's
relatively
kind of
quickly.
like seed
Yep.
treatments there, right? Where you need to be realistic of your expectations on where you're going to deploy these varieties in the future. We don't want to put them in our worst root rot field. Like, we still want to take that into consideration with our rotation and set them up for success.
Hmm. Well, and
Yeah.
and we've seen examples with like the varietal blends with the wheat midge trait, right? Where that we're trying to work in stewardship of the trait ahead of time to sort of, so we have to think about, just when we get genetic resistance, it doesn't mean that exactly that you can go wall to wall peas, not have to worry about it, and away you go. We still have to think about, like, this is another tool, but it's not a solution per se, which unfortunately I think we would all love just a cure, but those certainly, when we talk biology, doesn't usually actually work. So far more complicated than that. Now, Jason's got a good question on the moisture question. So you may know Jason Vogt, Laura Schmidt, in that he has been on the show and also you know each other. So there we go. In general, dry beans don't like wet feet, but is it soil texture or simply drainage? It's a good question. So if you had heavy clays, but well drained, which I think is an oxymoron, um, could you potentially be growing dry beans there? So I guess that question is perhaps something like adding tile drainage or having, really great soil aggregate stability, etc., in a heavy clay. What do you think? Would they do okay?
I think part of the trouble with dry beans, I always kind of think of them like the Goldilocks of pulses, where
Mm,
everything sort of needs to be just right for them to do their absolute best. So the right amount of moisture, right amount of temperature. Um, I do know when I think about them, just from my own experience with them, that they're going to be the first crop when I put them in a field where I'll see that compaction layer, where I'll see those roots go into that lateral plane in the headlands. Um, so I do think they might still struggle with working through some of those heavy clay soils. But at the same time, a lot of that challenge with them is just how much moisture is there, ending up with that rhizoc root rot, along with just kind of them not being super aggressive in the
right.
soil. But at the same time, I think they've surprised me over the years too. I also am kind of surprised just how much even biological nitrogen fixation they've been able to do on fields that have a history of dry beans, which we've maybe not attributed enough credit to them so far, just because we do fertilize them with nitrogen like a non-legume crop. I think there's potentials there, but I'd be curious to explore that further, Jason. I don't have a great question for you, but it's a really good consideration that I want to take a closer look at.
Okay. I will, Jason, if you could get some tiles in. There's still time. Get it in and we'll test that. Okay, we're going to hop to a clip. This is with Megan Reed with SAS Pulse talking about, is it a Phanomyces? And then I've got one more great visual I want to touch on before we move on from the Phanomyces question and talk about maybe some of the other things. But producer Jay, if you would, we'll go to a clip with Megan.
Yeah, so root rot, you're talking specifically about a Phanomyces, but we typically refer to root rot as a complex because there's more than just one pathogen. So we've got a Phanomyces, that's the real big ugly one that we talk about the most. Then we also have a number of different Fusarium species, Rhizoctonia, Pythium, and all of those different pathogens will set in conjunction with one another at different times throughout the growing season, or in the spring particularly. But we tend to call them a complex because one will set in and it just opens the door for the others to move in afterwards. And that's one of the things we see particularly with the Phanomyces and Fusarium is that we don't really know which one comes first. They typically are always present together.
Okay, so chicken or the egg scenario.
Yeah,
here.
a little bit, yeah.
Yeah. So gearing into a Phanomyces a little bit more, what environmental conditions does it like? Like obviously we're out in a very wet field, it's a good condition for it, but what else does it like?
Yeah, so Phanomyces specifically, when we talk about that pathogen, looking at the disease triangle, so when you have the disease triangle, you need to have all three of those factors satisfied. So you need a pathogen, a host, and the right environment. And so if we take this field, for example, we have purely saturated soil. We have a host crop, which is a pea or lentil. They're equal for susceptibility. And then I haven't confirmed in this field whether there's a Phanomyces here, but we could go out on a limb and say possibly, probably. Conditions specifically, though, when we talk about the environment, saturated soil, we tend to find it's worse where there's heavy clay and compaction. Fields that don't drain well, so water pooling and sitting like we're seeing here. Also, a really tight rotation. So the more inoculum you have built up in the soil with the Phanomyces, it compounds. It's like compounding interest. Every time you grow that host crop, you're going to add to that inoculum level. A Phanomyces particularly we see it really rearing its head and seeing symptoms when soils hit about 22 to 27 degrees Celsius, and it really loves pH between 4.5 and 6.5. So most of our soils in the province are neutral, but our topsoils are tending now to be a little bit slightly acidic, just below neutral, and that's due to a number of factors, fertilizer stratification, but just slightly acidic. Honestly, if we have heavy clay, saturated soils, tight rotations, it's the perfect environment for a Phanomyces.
Our sponsors for the Agronomists are Real Ag on the Weekend, the Farm Safety Roundup, and the Pulse School. From pulse seed quality and selection to Made in Canada varietal development and on to disease management, marketing development, and decisions, the Pulse School keeps farmers in the loop about pulse production. The Pulse School is made possible by support from BASF. Learn more at pulseschool.com. And we are back. Okay. I was trying to fix something with my light, you guys, and it didn't work, but that's okay. Okay, now, Laura, you've got producer Jay. Can we go to I think it's slide 4 of Laura's before we leave the Phanomyces and go to talk some Ascochyta and Anthros and all that. Wow, this is this is bonkers bananas. Okay, so talk to me about this image. This is insane.
Yeah, this is, I guess, a bit of a horror story. I was actually called to this field to look for pea aphids, and I went, I think we should talk about something else today.
Yes, I think so too. Yeah.
So these were two neighbors. For the fellow on the left side of the screen there, that's his first time growing peas, was just dipping his toes in the water, kind of learning a little bit more about incorporating pulses into his rotation. So love it. The fellow on the right has been growing peas in that field before and kind of that Aphanomyces you're really seeing rear its head here. There's a few other issues just in terms of some sidewall compaction, and you can kind of see that in the slopes and the drains. But what we're really seeing here is that impact of having peas in the rotation in the past with Aphanomyces root rot history. You can see they're also kind of sharing some water drains. So in the future, we're going to manage that field on the left like Aphanomyces is already there, because we do expect it to already be there. And kind of that expectation that we'll see it expand from those shared areas and those drains over time. But thinking about that when we're talking about rotation. There was one more picture that I thought about sending, but I didn't. But it was again, just yellowing peas. So you can get the idea.
Imagine the one on the right. Yeah. Okay.
And we'd gone to this field, the peas were yellowing, it was a relatively dry year, all these things. And then we got looking at the rotation history, and peas hadn't been in that field for 14 years. So
Wow.
we're not really talking about eradicating Aphanomyces. It's bringing it back down to low enough levels that pulse production is still profitable. Because
Right.
otherwise, we don't want to be growing that field on the right. But just a really great illustration of thinking about that last time peas were grown in a field and that implication it's going to have on the rotation.
When you sent this, Laura, I honestly thought this was like two pictures you had put together, and then I realized this is the same. Like that's a property dividing line. That's not
Yeah.
two pictures that you put together. So that is amazing. So there you go. That's how devastating this can be, and yes, and speaks volumes to, of course, knowing your field history and what you do with it. So crazy. Now there is one more. I actually, if we can go to the next slide, Jay. I just want to yeah, we just had a conversation about killing weeds and difficult to kill weeds in kochia, and this is just I love the tumbleweed here. Like or I would love it if it weren't such a jerk. But this is what it looks like, everybody. For everybody in Ontario that doesn't deal with kochia, that's the tumbleweed.
Yeah, and I guess just to illustrate the opposite view of what's behind the camera is all 6 of these little rolling lines originated from the same single patch in the headlands. So that
Oh
patch
goodness.
management is really what it illustrates to me. It also is
Yeah.
kind of my plug to we need to maybe think about one step past this soybean honeymoon we've been in, and 2 shots of glyphosate isn't going to cut it for kochia anymore. But what I really wanted to talk about or bring up with kochia, I know you guys covered it quite a bit with water hemp last week, so I don't want to belabor it, but we don't even test for group 2 resistance in kochia anymore in the prairies. We just assume it's all group 2 resistant. So I think that's just important to bring up when we think about pulses, where we're really relying on groups 1, 2, and bentazone in 6. So not a ton of in-season options. We need to think of a longer management strategy when we're talking about kochia specifically, or else those tumbleweeds will keep on tumbling.
They sure do. It's just what they want to do, Laura. Just let them do it.
Absolutely.
Just kidding. Please don't. Okay. So yeah, and you're right. We did talk a lot about kochia last week as well, but it is one that it's the gift that keeps on giving, as this shows. So it's going to come up many times, and definitely one of those difficult ones to manage for sure. Now that does relate to Michelle. Well, I do want to talk about disease management in pulses, and then of course we have an added layer of difficulty in that we also are dealing with fungicide insensitivity and or resistance. So we're going to talk about that as well. Let's go, producer Jay, if you would. I want to talk anthracnose and ascochyta. We'll start with slide 1, and this is in lentil. So Michelle, walk me through the work that you're doing on these. Let's start with anthracnose to start with. How difficult of a problem is this to try and solve?
Well, people in the chat will probably love this because I saw they were commenting on my saying depends before, but it depends
It
on the year.
depends.
So the story here is back in 2018-19, there was some suspicion that fungicides for anthracnose of lentil weren't working as one would expect. And so if some people, probably everybody knows, but just in case, anthracnose is a fungus that causes a foliar disease, a disease of the stem and the leaves in lentil. And the pictures here are just to show what it looks like. So when it starts out, there's these really tiny water-soaked lesions, and then the one where I accidentally put the lesion over the word lesion over top of the lesion is a bigger gray water-soaked lesion with my thumb in there for scale. And then it can cause leaves to fall and damages the stems, especially low down close to the ground, and that can cause the plants to lodge, and that's where you're really in trouble. So back to the story of my study, then it was suspected that there was an issue back in 2018 or 19. So in 2020, I started to lead surveys of commercial fields in Saskatchewan, where what I asked for is farmers or agronomists or the Saskatchewan provincial ag extension people to bring me samples of suspected anthracnose. And then Zakir Hussain, a researcher in my group, developed several different molecular based, so DNA based assays where we could extract DNA from a sample and then determine if there was a mutation there. That if this mutation is there, the pathogen, the fungus, is really resistant to group 11 or strobilurin fungicides, which are a really common active ingredient that the majority of fungicides that you might use to manage lentil anthracnose contain these compounds. So it's not good. It's a problem if you have insensitivity or resistance. And so in 2020, back to the depends, 2020 was a wetter year. So I got a lot of fields and we got a lot of samples. And anthracnose was a fairly big problem. But then the survey continued in 2021 and 2022. And 2021 was hot and dry. So there was almost no samples. And the ones we did get, the disease would be so mild that we couldn't get enough DNA to get a meaningful result out of it. And then 2022 was a little better. But the overall summary outcome is that it's very widespread. There's many fields have insensitivity. So my usual advice is assume that you have it. Assume that you have insensitivity to group 11s, but not to group 3 or group 7. So if we could go to, I'm seeing what number it is, slide 4. Where I just talk about what do I mean by these different active ingredients. So group 11 or strobilurins are the common one, the one where there's the insensitivity. And they're something that works well, and they work on fungal respiration, so how fungi generate energy. And then 3 and 7 are kind of intermediate in how likely it is for resistance to develop. So we focused on those second as a second priority. And they're a little harder to study. There's not just one well-known gene and one well-known mutation that confers this resistance or insensitivity. So instead, we had to isolate the fungus from the plant and grow it on a plate and then add the fungicide to the media. So it's a bit of a slower process. But the good news is that when we compared isolates from a colleague's collection from decades ago before these compounds were used, there wasn't any difference. So it's fairly unlikely that in any given field, I can't say it absolutely doesn't exist, but we didn't see any evidence of it from our small sample size. So group 3 and group 7 probably will work. And then there's the contact-based fungicides that contain chlorothalonil, or they're things like Echo or Bravo or the trade names that you're more likely to know them by. And they seem to work the best by some work that Saskatchewan Pulse Growers commissioned. But they're contact-based, so they're not systemic. They don't get into the plant, so they have that downside. And that's what this little picture where what I meant to draw on this picture was I just drew it in paint. So it's not a very great picture, but it's it's supposed to be a fungal cell. Where the group 5, the M5 is on the outside of the cell, just hitting the outside. And then the others actually get into the tissues and can, depending on the compound, have a systemic impact. So there's kind of some things to weigh when you're considering using a fungicide and which one you might want to use.
So now, is there a reason, and Laura, I'll ask you this too, because I know you've done some work in Manitoba with insensitivity. Is there a reason when we're talking fungicides that we say insensitivity versus resistance? Is it like technically what we do, or is it just because it seems to be the thing to do? Do we know why we use this term differently with fungicides?
The biggest reason I use it is to distinguish it from herbicide resistance and weeds.
Okay. So it's
Um,
for clarity. Okay.
Then another reason is that there's gradations, like it's not black and white. It
Okay.
depends again, um, and it depends on a bunch of things. Like
Perfect.
there could
Okay.
different even within, say, my collection of isolates where we've tested them genetically and are pretty confident they all have this mutation, so they should be insensitive to group 11s. The concentration that you have to use in media varies. So it's
Oh,
not
okay.
like it's not a black and white, like they absolutely die if they
Okay.
touch group 11 fungicides or they don't. There's like a
Okay.
gradation. And then
Right.
with other active ingredients, that could be even more pronounced.
Okay. So it's not like an on off. Okay. So Laura, in Manitoba, there has been work on Megasphaerella blight of pea, right? Being insensitive to some products. So how do you broach that with farmers with that discussion about in crop fungicide applications? How are you broaching the group 11 question?
I'd say so this is in our peas, of course, with Microsphaerella blight. So far, testing's been pretty limited. So kind of 2 years. The place we were sending those samples, it was kind of a proprietary test. They could only accept so much. So we were just kind of exploring, hey, we've got a lot of pea fields and a lot of disease. Is it resistant or insensitive? So we sent them off for testing. So I should mention that it is fairly limited. We did get a good kind of snapshot across Manitoba, but it's again only about 20 fields. But we were finding, these group 11s alone were not working to manage these diseases in small proportions of the disease population in these different areas. The interesting part is that we had more insensitivity kind of in central Manitoba, maybe where some of these strobies have been used a little bit longer term in other crops. We're seeing that bleed over. Versus peas in Western Manitoba, where they're grown a lot more frequently. Like Central Manitoba would be kind of a newer pea growing area. So to see more insensitivity there versus somewhere we've been growing peas for a while. But when I talk to farmers about it, realistically, we already kind of know that the strobies are where we're going to develop resistance or insensitivity first, just based on how they work and that mechanism of the target site and stuff. So a lot of our chem companies are already, it's hard to get a product that's a group 11 alone that you'd be spraying at that time. Like it's pretty uncommon to use a headline or an acapella alone when you're actually targeting Microsphaerella blight in a pea crop. So it's not common, but it does still happen. So we do still like to talk about, let's lean on some other stacked active ingredients. It is still a component of several fungicide products for sure, but it's never there alone typically when we're actually using it in our peas.
Okay, that makes sense. Jason's got a good question about nitrogen, but I'm going to leave it for a moment because I don't want to I want to cover just one more thing. Michelle, with your slide 5, producer Jay, the why of the insensitivity. So I do want to, so on that point, so of understanding that it's a sensitivity or insensitivity, so it's a gradient there, it's not necessarily black or white, and thinking about, Laura, what you've just said about where it occurs and the use of the strobies or the use of, or perhaps more pea crops in rotation, how this develops. So Michelle, walk me through sort of, because it's similar but not the same, so walk me through how insensitivity sort of evolves within the diseases.
Sure. So the pictures on the bottom here with the little black and red are intended to show that. So initially you'd have the black, the sensitive fungi are the ones that's the most common. And then if you apply a fungicide, those ones will, for the most part, die or not grow or not reproduce. And the ones that are not sensitive have an advantage. And so they don't die. And then they make up a bigger proportion of the population. And then as they grow, that's kind of represented in the population. And so then if in this picture, if you were to apply fungicide again, you can imagine it would soon become mostly red.
Right.
And then what Laura was saying reminded me of a few other things I could add to my previous results. That we also found that there was often a mixture. So if we'd get a single sample, it would often contain both sensitive and insensitive. Or within a field, we'd get 5 or 10 samples within the field, and some of them would have only insensitive. It was fairly rare to get only sensitive, but it did happen. So that what that means in a practical sense could be that if you applied a fungicide that had a group 11, and as Laura said, it's very rare to have only a group 11, but that if you were relying on that action, then it could still have some benefit, especially the first time, because there's still some sensitive population out there. So you might see some disease reduction. And maybe more so depending on the disease, like Mycosporella blight in pea or Anthracnose in lentil. It's not that uncommon to just spray once, but then Ascochyta blight of chickpea, people might spray only once, but they might spray 5 times. So there you have a lot of selection pressure within one season.
Yeah, within a season. So there are similar aspects to how resistance develops in weeds as well. But just like certain weeds are more prone to this, where do some of the diseases fit on the more likely, less likely? So in looking at something like Anthracnose, is it quite likely to develop insensitivity, or is it less likely?
It's fairly likely, but Ascochyta blight of chickpea is even more likely just because it reproduces more times within a single
Right.
growing season. And then Mycosporella blight and Anthracnose are both, they can reproduce multiple times, like they keep spreading with every
Right.
time it rains or there's wind, the spores spread, and that gives an opportunity to reproduce. And so the cycle can happen multiple times. That's what the polycyclic in here means.
Yeah.
Whereas some diseases, it's just once in a growing
One.
season, and
Yeah.
then they're slower.
Which and same again with certain weeds, right? Some weeds will flush several times, or some weeds, they're gonna emerge at one time and try and complete their life cycle, and that's it. So some are gonna be less likely. Also, I'm going to assume again the lots of spores, but it's my understanding that aren't diseases kind of just gross that way and they all just produce lots of spores? Or is there a difference in how many they produce?
There is a difference, but you're right. They all
Okay,
tend to
thank
produce a
you.
lot of spores.
Yeah, that's what I thought. Yeah, okay. Producer Jay, let's go to our last read of the night, and then we'll tackle some of these nitrogen questions to wrap up the show for tonight. The Agronomist is brought to you by the Pulse School, Real Ag on the Weekend, and the Farm Safety Roundup. Keeping safety front of mind is all about communication. With agriculture expertise to help keep farmers, their families, and their workers safe, the Farm Safety Roundup is a podcast series focused on important conversations with a team of ag specialists at Workplace Safety and Prevention Services. Check out the podcast on YouTube or wherever you get your podcasts. Okay, so a few key points here is that one of the reasons why we want to grow pulses in rotation, there's a couple of reasons. Markets are one of them, sure. Cash flow is one of them, but rotation advantage is a big one, and so is the fact that they fix their own nitrogen and even leave some nitrogen, unlike those greedy soybeans. So now at the same time, there are differences, of course, between crops, between what they leave behind, and that's sort of another whole. And we actually have a slide that we can go to, but Jason's got a question where with some of the work that Krista McMillan did, what's Laura's feedback on where we are with N rate for dry bean production? Recent research, this is Kristen's, recent research shows we don't need as much as previous recommendation, but Jason is not convinced. Laura, are you going to try and convince Jason, or do you side with the research?
Yes. That was part of why I was like looking like this. I was trying to find the new protocol.
Okay. Yeah. If you want a minute, you can go and find it. That's fine.
We recently it's around the funding cycle, right? So it recently closed up that nitrogen rate study, but it's evolved. It's continuing on now, where there's 2 separate ones, as I understand it, moving forward. It's gone through its first field season here. I saw it in the field. I was seeing these greenness differences in the treatments. You could see which plots were darker, which were limey. That always gets me excited in dry beans.
Sure. Yeah.
But the new iteration is kind of looking at that combination of how can we actually get this crop to fix some of its own nitrogen, this biological nitrogen fixation. Can we quantify that for dry beans in Manitoba soils? We've been testing inoculants off and on. Some success there, but the trouble is they're not, the ones that are successful aren't commercially available in Canada. So some challenges in the inoculant side and this biological nitrogen fixation side. So yeah, we're looking to fertilize these with nitrogen for a little while here until research keeps going there. Like Jason mentions, we are seeing kind of that response there where economically we're not seeing that return on investment to increase nitrogen rates in dry beans from the small plot studies as well as some of the on-farm trials. So we are seeing kind of that economic benefit to us walking back some of our nitrogen. But I think another consideration there is just how much moisture we've had in a growing season that some of these have been ongoing. Whereas this last year was kind of our first return to a bit more early in the season and starting to see some of this. So I think it's one to stay tuned. John Hurd always says, though, when will we ever figure out nitrogen in dry beans? Like, why are we still doing it? But I think there's some value.
He spent his whole career, okay, maybe not looking at dry beans, but looking at nitrogen. We should bring Soil Safari John back on the show. He hasn't been on in a while.
He's so great.
Yeah, he is. Okay, but on that note, could we bring up producer Jay, Laura's slide 2? Please, we'll maybe just touch on this before we have to end it, because, and one of the reasons that I'm bringing this up is a couple weeks ago we had an episode on rotation impacts, and Manitoba is one of the only provinces, I think, that actually has some really good crop following crop data that is actually out there and available. Other provinces don't do this, and we have lamented on this show that more of the crop insurance corporation should do this to actually quantify some of the impacts of that rotation. So, Laura, walk us through this just quickly, but this is from crop insurance in Manitoba, and this basically shows the impact of the previous crop on the potential yield bump, right, that you may get with some of these.
Yeah, so I didn't realize this was a Manitoba thing. Okay.
It is, Laura. You should be very proud.
Narrowing it down to just my crops. So on the left, we have kind of our previous crop. So each line is either soybeans, peas, or navy beans. And then the columns are the crop going into that. And what that data is showing is the average yield response of these crops grown on them in a percent base. So 100 would be just kind of that. It's the same as average, and then everything highlighted in green is a bump versus kind of just that usual average. So for soybeans, those cereal crops, canola, flax, sunflowers, that's where we're seeing a little bit of a positive yield bump following soybeans. We don't generally attribute that to a nitrogen credit, but there are kind of some of these non-nitrogen carryover benefits to pulse and soybean crops. And we're kind of very exciting kind of space in research right now is just looking at what's happening below ground following some of these pulses. They're accessing nutrients in a bit of a different way. They have a lot of benefits on that mycorrhizal fungi structure, which you see this big dark green blocks of flax following peas, this 126% yield response. Those peas have a really great AMF structure, connecting that on for the next flax crop and accessing that phosphorus in a big way is really what you're seeing there. But also just how they're impacting the microbial community is really poorly understood, I would say, and like a really exciting space in research now where it's heading. So I think that's exciting. The other thing we say with peas and lentils is they're also shallow rooting, so there's more deeper soil moisture for that next crop. But you can see a lot of green on this table in terms of seeing little yield bumps, some of them being bigger. The dry bean one, I wish I had pinto beans and black beans because market classes matter so much in dry beans, and we only have navy bean available. So some of this, I wonder, are we seeing not all that nitrogen fertilizer we put down getting used up? Are we seeing that carry over into the next crop? Or is it just that some of these other pulse effects are happening more than we think in dry beans too? And that's why we're seeing more often this, 110% plus response to them versus the peas. So I love this data. I would love to spend more time with it.
You know what? You can. Just from here till the holidays, just dig into this. So Pete says, where is wheat as the previous crop? Pete, you can go find that. Laura just grabbed the ones that we were talking about tonight. So it does exist. As you note, there across the top, it says spring wheat and winter wheat. This, for at least for Manitoba, it exists. And what I will also point out, especially building on those conversations we've had about rotation, you'll note soybeans on soybeans below the 100. See how that works? Navy beans on navy beans below the 100. So there you go. These are important points when we're talking about rotation benefits. But yes, Pete, you can go and look at how things do after winter wheat. You can switch this table around. So there you go. That man's got a one-track mind. I'm telling you, it's all about wheat. Anyway, okay. This is fantastic, and you're right. It'd be great to have. We could expand this. So there you go, Pete. I have the chart. Yeah, exactly. I'm sure he'll bring it up next week. Okay, and this is my shout out to each province to go and do this with your data. I think it's fantastic and tells the tale. Even though, Laura, as you point out, we probably don't know all we need to know about why rotation has the impact that it does, but at least we'd have some data to show what we can count on with a crop following another crop. So there you go. Okay, so we are out of time. Michelle, we're going to, as we wrap up here, what do you have exciting for next season? Does all this work continue for next year? Are you wrapping some things up? Or are you starting anything new? What happens for the 2025 season?
Well, the anthracnose stuff is wrapping up. Root rot work continues, and I have one final year of intercropping with chickpea and flax, which is something we just ran out of time to talk about, but I'm very excited about.
What do you call a chickpea flax intercrop? Chacks? Flick peas.
Yeah,
You could
flick
call them
pea.
flick
Flick
peas,
pea, I
good.
think, is a popular one. I usually
like
just call
flick
it
pea.
chickpea flax. I'm kind of boring that way, but flick
Yeah.
pea I've heard.
I like flick pea a lot. I really like naming intercrops. So there you go. Flick pea is very good. Okay, awesome. Okay. Well, next intercropping episode, you'll have to come and join us. And Laura, now you did mention a couple of the on-farm trials, lots of those things going on. And we are, of course, also into the busy conference season. So what will keep you busy this winter? Are you crunching numbers or what will keep you busy?
I call it extension season because it's just me talking until somebody pulls me off. Coming up in January, we'll be at Ag Days for the Manitoba Pulse and Soybean session, but I'm moderating a session with some farmers who have tried new legume crops in their rotation.
Ooh.
So lupins, faba beans, black beans in northwestern Manitoba up by Russell. So we're going to talk about some of the trials and tribulations of some of these little crops and see if they have a fit in Manitoba.
All right. Lupins are pretty, like super pretty.
But they also, I don't want to go on a tangent.
Okay.
They don't love our basic soils.
What can I say? Maybe they're an Australia thing. Okay. All right. And thank you everyone for joining us. Of course, in the comments, a reminder, of course, next week we'll have our wrap-up episode. So join us then as well. Thank you, Laura. Thank you, Michelle. Thank you, producer Jay. And we'll see you next week, everybody. Cheers.
Thanks for having us.